Hello and welcome to Learn with Roblox. Today's video is going to be about sector areas and arc lengths within circles. So let's go over the formulas for those. If you have a circle with a central angle of theta that cuts out a sector, the arc length is shaded in red and the sector area is shaded in blue here. And let's go over the formulas for both of these quantities. I'm going to zoom in here for a bit. So for the arc length, the formula you need to know is if you're using degrees, it's theta, the angle, divided by 360 degrees times 2 pi r, which you might recognize as the circumference of the circle. For the radians, the formula is just r times theta. A lot simpler. And then for the sector area formula, if you're using degrees, you once again have theta over 360. You can almost think of this as specifying what fraction of the circle you're using. And then you multiply that by now the area of the total circle, which is pi r squared. And then if you do this in radians, the formula is just a little bit different. The formula is just 1/2 r squared times theta. So now, let's get into some problems dealing with these formulas. In this first problem, I've given you that the circle has a radius of 3 and the central angle we're going to use is 90 degrees because I've drawn a right angle in there. So now let's find the sector area and arc length that I've shaded in red. Let's start with the arc length first. The formula for arc length is just theta over 360, because I'm going to use degrees, times the circumference, which is 2 pi r. And we know what theta and r are, so we can just substitute those values in and solve for the arc length. So theta is just 90, and r is just 3. Let me step out of there for a bit. And then now we can just simplify this expression. 90 over 360 is just equal to 1/4. And then 2 pi times 3 is just 6 pi. And then finally, 1/4 times 6 pi is just 6 over 4 pi, or that's just 3 over 2 pi, if you simplify that fraction. So that's it. That's how long the arc length is. And if you want to put that on a calculator, it roughly is 4.71 units. Let's go to the sector area. So remember, the formula for sector area is pretty much the same as the arc length, but instead of using 2 pi r, you just used pi r squared, because that's the area of the total circle. So once again, let me just rewrite that. Theta over 360 degrees times pi r squared. And now you just substitute in the right values. Once again, theta is just 90 degrees, and r is 3. So 90 degrees over 360 degrees is just 1/4, once again. And then there should be a square there. 3 squared times pi is just 9 pi. So in total, the sector area just ends up being 9 over 4 pi. Oops, I cut out the 4 there. And once again, if you put this into a calculator, it is about 7.07. And note for the units, because we're squaring the radius, this would have units of units squared, whatever those units are, while the arc length would just have units without the squared on it. Let's move on to the next problem down here. In this problem, I've given you that the radius of the circle is 7, but the angle, 2 pi over 3 radians, is not the angle that you can use to solve this problem. The angle you're going to want to use is this angle over here. And how can you find that angle? What you need to know is that the sum of the degrees in a circle has to be 2 pi radians in total. That's the total number of radians in a circle. So if we just subtract 2 pi over 3 from 2 pi, we'll find the number of radians that this angle is supposed to be. So let's do that. 2 pi minus 2 pi over 3. Well, 2 pi is just 6 pi over 3. And then that's just 4/3 pi radians. So this is our theta. And we can use this to now solve for the sector area and the arc length that I've shaded. So let's do that. First, I'm going to find the arc length. And remember, the formula for arc length when dealing with radians is just r times theta. So we can do that pretty easily. R is just 7, then theta is just 4/3 pi radians. And if you simplify this, that would just be 28/3 pi. And that's how long the arc is. If you want to put this into a calculator, it ends up being roughly 29.32. Let's go deal with the sector area now. The formula for sector area is a little different. The formula is just 1/2 r squared times theta. So let's just plug in r and theta into this formula and solve for the sector area. So that'd be 7 squared times 4/3 pi radians. Okay, so 49 is just 7 squared. So you have 1/2 times 49 times 4/3 pi. If you do all that multiplication, you'll get 196/6 pi. And if you divide the numerator and the denominator by 2, you can simplify this even further to get 98/3 pi. And that's the answer for your sector area. And if you want this as a decimal, it ends up being roughly 102.63. And the units on this would once again be units squared. Whereas the above arc length would just have units as the units, whatever those are. So for example, if this was in feet, the arc length would be that in feet, and the sector area would have feet squared as the units. Let's move on to some harder problems now. In this problem, I've given you that the sector area is 30 units squared, and I want you to find the radius of this circle. To do that, I'm going to write out the sector area formula and solve for the radius. Which formula should I use? Notice that the angle I've given you is, let me zoom in a bit, 3/5 pi radians. That means we use the radians formula for sector area. And remember, that is just 1/2 r squared times theta is equal to the area of the circle, or the sector of the circle. So now let's just plug in theta and the area, and that should allow us to solve for r. So let me just move down here. This would just be 1/2 r squared times 3/5 pi radians. And this has to be equal to 30. Let's simplify this even more. 1/2 times 3/5 is just 3/10. So it's 3/10 pi r squared has to equal 30. Then just multiply by the reciprocal of the fraction on both sides to eliminate the fraction. So multiply by 10/3 to eliminate that fraction. And then you'll be left with pi r squared is equal to 30 times 10/3. Or that's just 300/3, which is just 100. So just divide by pi on both sides to eliminate the pi here. And then now that we have r squared is equal to 100/pi, just take the square root of both sides. So all you need to do is just take the square root of 100/pi to get the radius. Put this into a calculator and you get roughly 5.64 is the answer. So the radius is just 5.64 units. In this problem, I've given you that the arc length is 14, the central angle is 31 degrees, and using that, I want you to find the area of the circle. To do that, what we can do is first solve for the radius, and once we have the radius, we'll know the area of the circle. So first, let's find the radius of this circle. To do that, let's use the arc length formula that's in degrees. So that's theta over 360 times 2 pi r is equal to the arc length, which is just 14. And we know that the angle is just 31 degrees. Now, all you need to do is just simplify this. So if you do 31 over 360 times 2 pi on a calculator, you're going to get about 0.541 times r is equal to 14. And from there, it's just a matter of dividing both sides by 0.541. And if you do that, you'll get that the radius is roughly equal to 25.88 units. So now, we can use this to solve for the area. So now, we know that the area of a circle is just pi r squared. So just put in 25.88 into r, and we'll be done. Oops, the eraser is not functioning. Put this into a calculator, and the total area, which I'll just write as A and move out of the way, is about 2,104.16 units squared. And that's it. That's the area of the circle. Let's move on to the next problem. Here, let's read this word problem. It says, a sprinkler in a 400 square foot lawn can spray up to 12.4 feet, and it rotates 256 degrees. What percent of the lawn is watered? So all we need to do is just find how much area this sprinkler can cover, and then just compute the percentage. So let's do that. The area that will be covered is just theta over 360 times pi r squared. And we know our angle and our radius. The radius is 12.4 feet because that's how far the sprinkler can spray in one direction, and theta is just 256. So let's plug those numbers in. So theta is 256 degrees, and r is just 12.4. And then this is just a matter of computing it on your calculator. If you do 256 divided by 360 and multiply by pi times 12.4 squared, what you'll find is that the area is roughly about 343.5 feet squared. And then now, all we need to do is compute the percent of the lawn that's watered. To do that, all you need to do is just divide this by 400 to get what fraction is covered, and then just multiply it by 100%. And if you do this on your calculator, you should be finding that the percent just comes out to be 85.88%. So that means we cover this much of the lawn. So the sprinkler does most of the job for us, which is good. Let's move on to our final problem of the day. This is the hardest problem of the day. In this problem, I've given you that the radius of the circle is 4, the central angle is 120 degrees, and I want you to find the area that I've shaded in red. Well, that seems like kind of a strange shape to find because it's not exactly the total sector. So how can we find this shape here, or the area of this shape? The way I would do this is think about the different shapes we have inside of here. So first, I have this whole sector. I'm going to shade in them yellow like that. And notice that I also have this triangle here that I'm going to shade. So the way I want you to think about this is if I have the total sector like this, and then have the triangle like that, and if I subtract these areas, what area will I be left with? I'll just be left with the area of that top little piece there. So all I need to do is find the area of the sector, find the area of this triangle, subtract them, and I'll find the area we want for this problem. So let's do that. To find the area of the sector, this one is pretty straightforward, as we've seen how to do this many times now. The area of the sector is just theta over 360. I'm just going to immediately write that as 120 over 360 times pi r squared. And our radius is 4, so 4 squared times pi is just 16 pi. And if you put this into a calculator, that would be about 16.755. So this is the area of the sector. We'll need that for later. That was the easy part. Let's find the area of this triangle. That's going to be a little harder to find. So what I'm going to do is I'm just going to draw this triangle in this space here. So what do we know? We have a triangle. We know that if this is 4, that other side is just the radius of the circle, so it's also 4. And we know this angle is 120 degrees. How in the world can you find the area of this triangle? What I'm going to do is I'm going to cut this triangle in half down the middle. So I'm going to cut it like this. And now I need to think about what happens. I've cut this angle in half here, so I know it's 60 degrees. This angle is just 90 degrees, right? Because I just drew a perpendicular to that line. What does that mean for this angle? Well, all the angles in a triangle sum up to 180, so 90 plus 60 plus 30 would get you 180. So this is a 30-degree angle. Well, wait a minute. This is a 30, 60, 90 triangle, which means what we can do is we can find what the sides in this little triangle are, and then maybe that'll help us find the area of the triangle. So I'm just going to draw this 30, 60, 90 triangle again. I'll just draw one of them. So I know this is 60, this is 30, and that's 90. I know that this is 4. Remember, in a 30, 60, 90 triangle, the 60 side corresponds to, or the 90 side corresponds to 2x, the 30 side corresponds to x, and the 60 side corresponds to x times square root of 3. So if I know that 4 is equal to 2x, I know that x in our ratio is just going to be 2. So I can now fill in the other sides. The 30 side is just going to be 2 units tall, and the 60 side is going to be 2 times the root 3. So now this is the triangle. Now I fill in the other half, like that. Well, these triangles are the same, right? So this part down here is also 2 times root 3. And notice how I can find the area of the triangle now, because area is 1/2 base times height. This 2 over here is just the height, and this total side is just the base. And the base is just going to be the sum of those two little parts. So if we just add those up, 2 root 3 plus 2 root 3, that total base is just going to be 4 root 3. So now we can find the area of this triangle using 1/2 base times height. The height is 2, and the base is 4 times root 3. Put this into a calculator, and you'll get about 6.928 as the area of that triangle. So now, let's quickly substitute this back into our shape subtraction formula, where I subtract the sector minus the triangle. So the sector is 16.755, the triangle is 6.928. So I just need to subtract these two numbers. And if you do that, you'll get the final answer, which is 9.826 units. And that's it. That's our answer for this problem. We were able to find the area of that strange looking piece just by simply subtracting two other shapes that we knew how to find the area of. If you enjoyed this video and it helps you, please consider leaving a like and subscribing. Thanks for watching.